Hi, welcome. Today we are going to look at sets. Remember, sets is one of the data structures in Python, and previously we've looked at tuples, and then we've also looked at lists, numbers, and strings. So today let's look at sets, and sets are very interesting because they have some few peculiar characteristics, and these characteristics of sets are usually attractive when they want to set interviews for Python. So just follow this video and make sure you understand the key differences between sets and other data types. So let's just go straight away. The first thing is we are going to create two sets, and just to show you that there are two methods of creating sets. So let's say the first one is using a set function. Then you pass in a list. You wanted your maybe your 1, 2, 3. This is your first set. Now let us create the second set. My set 2, for example, equals to, now you can use your curly braces, and then let's just put 3, 4, and then 5, for example. Okay, so let's check if these are sets or what are they exactly. So let's use the type function, and then we say my set 1. Next one, we'll print the second one to print type. Then we use the my set 2 here. Now we remember we can either run from here or from here. I'll just run it from here. So good. Set 1 is a set, set 2 is a set. So perfectly, we have successfully created the sets. Now let us see if we wanted to create an empty set. What if we take off all these elements from here? So we expect this to be a set and this to be a set when we run these same commands. Even though they are empty, let's run them. Okay, so what do we see here? We see that set 1 only is a set. My set 2 is a dictionary. So here, what is the conclusion? You can only create an empty set by using this set function. So remember that when you're creating sets. Okay, so let's put back our numbers there. Let's go back, put our elements of our set. 1, 2, 3. Don't forget to put the list. Let's put the list there. Now we pass a list to this function. Okay, then we put our 3, 4, 5. Good. Now we have our set there. Okay, so also just like with the lists, you can also add values to sets. So let's just see, for example, we want to add a value to my set 1. So we'll just do my set, and the method to use here is just dot add. So let's just add, say, number 4. Then instead here, I'll just take off this one. Then I just print my set, not the type again, because we've already seen that. Just print it normally. So let's check it out and see. Run that. What do we get? We get 1, 2, 3, and 4. So we had our 1, 2, 3 here. Then our 4 just got added with the dot add. So what if we wanted to add a series of numbers? Say another, let's say, add a set to this set, like you would use dot extend with a list, So let's try and see. So let's say we wanted to add 4, maybe 8, and maybe 7. So let's run that and see what will happen. Run it. What do you get? You get an error. So because first of all, even if we put the list there, let's put the list and run it again. Run that. You see you get an error. Why? Because the right function to use in this case is actually update. So instead of dot add was for a single element, and dot update is for a list. So what do you get now? You get now 1, 2, 3, 4, 7, 8. Okay, so I will want to show you something which is peculiar about sets. The first characteristic that is very interesting to remember is that, okay, I'm going to use this 2, 3 here like this. I'll just use 2, then I'll use 3 here, then leave the 7. So let's run that and see what happens. So you see what happens. We just get 1, 2, 3, and then 7. We don't get 1, 2, 3, maybe 2, 3 before 7. So it has taken away the duplicates And that is a very important thing to remember about sets. Sets take away duplicates and they only keep the unique value. So at times when you're doing your computation, you transfer from a list to a set because you want to be able to eliminate the duplicates, then maybe continue your operations if your operations don't need duplicates. So remember that for sets. So good. Now that you know that sets don't take duplicate values, let's move on now to see how to remove values from a set. So let's say we want to remove, say, this 3, for example. So we'll go there and then we'll say, let's come here. Let's put our 3 there. So we are going to do my set. And since Python is English, we just put dot remove. Good. So let us run this. Now let's run this. So what do we get? Our initial my set was 1, 2, 3. Now we've done the my set dot remove and we've gotten out 3 from here. So now let's see one interesting method when you're removing. Maybe when you'll be writing some complex formulae, you want to have the option. So now let us try to remove 4. We know clearly that 4 doesn't exist here, but let's try and see. And we know clearly, I'm sure we know that we are going to get an error. Okay, here when you do the dot remove and you do something like 4 which doesn't exist in the list, it throws you an error. But if you use, for example, instead of dot remove, you use discard. You use discard. Okay, see what happens with discard. Let's run it. In that case, okay, you see they checked, there was no 4, but it didn't throw us an error. It simply printed out the list as it was. So let's use now that, okay, we know that there is 3 there and we are asking it to discard 3 and we see how it's going to behave. Let's look at that. Okay, fine. So if you notice clearly, the 3 here is gone from here. So what is left here is 1 and 2. So clearly, if it goes and it doesn't find the element here, let's say when we had the 4, then it will just give us return us the original list. But if it goes and it finds the element that we want to discard, then it is going to just discard that element and give us the remaining elements in that dictionary. Okay, that's good. So now let's move on then. So let's go. Now I'll just go on, and the next thing is to look at the interesting method in sets, which is usually an intersection. So at times we want to find out, okay, what elements are common between this one and this one. Like for example, we expect 3 to show up. And if you remember, intersection with sets, just like sets in high school sets. So let's just do that. Let's just go straight away and do my set 1 now dot intersection. Then now we say, okay, give us all the intersection that you have with my set 2. So let's run it, and then let's just say we call this uh, let's just give it a name, my set 3. Let's just give it my set 3. Okay, so my set 3 is an intersection of these two. Then we print out now my set 3. So let's run that and see what we get. So good, just like we expected, we see that we get 3. So it got the intersection of this and this and this, and it gave us 3. So another interesting method that you need to look at in sets is the times you want to find out what is the difference between this set 1 and set 2, which means that, okay, what do I have in set 1, 1, 2, 3, that when I look at set 2, I don't have them. They are not found in set 1. So let us look at it. So let's say my set 3 is now set 1, and then we call, just like Python is English, plain English, just do difference showing up here. So we do the difference. Now let's print it and see. So you get 1 and 2. So what is it saying? It is saying that in my set 1, the difference between my set 1 and my set 2 is the fact that we have 1 and 2 in my set 1, and then the rest we don't have because of this 3. You know, the 3 is found here, so we took away the 3. So it's like, what is peculiar in my set 1? So you can look at it the other way around. Let's go to my set 2 against my set 1, and then look at the results here. Let's run it and see. So you see, in this case you have 4 and 5. So what is it saying is that the what is not found here, which is here, is the 4 and 5. Okay, good. And now let's look at one last major thing with sets. Now let me show you. If I want to get, say, this element, for example, in of the set, for example, I want to get this element. So what let's try and see. Normally with your your list, you would just simply say, give me maybe the first element. What's the first element? And you could even at times even change it, say first element should be 1 or something like that. Okay, let's try let's just try printing this. Let me just take up this one. Let's just try printing this one for the set and see. Okay, now let's run it. So let's run this now. Good. You see, you get an error. So they say the set object is not subscriptable. So it shows that the set object, that is another important thing to note about the set. They are not ordered. That is why they talk about ordered. They are not ordered like lists are ordered. You see this 1, 2, 3, they are not ordered. So when you try to access the first element, no, you can't. Try to access the second element, no, you can't. So remember that sets are not ordered. So for example, if you wanted to get maybe say the 2 here, then you would be forced to use a function like if, say for example, 2 in maybe my set 1, for example, then now you say maybe print for example 2 found, 2 is found. For example, it could be number 2 is present in the set. So let us run this. So you see, that is how you're able to find, they say your number 2 is present in the set, because the function is saying if you can check in my set, which is my set, if you find 2 inside my set, then just print me this statement and tell me, okay, I have seen number 2 in my set. So I hope you enjoyed this video, because if we have to summarize again, the key thing about the set is that it doesn't take duplicates, and the other thing about it is that you cannot really index a number because it's not ordered. You can't access this, say I had to go to use this if statement, this whole thing, before I was able to access an element here. So hope you like the video. If you do, click on the like, share the video, and see you next video. Thank you.